in one soap bubble is 3 times inside the second soap bubble. The volume of the two bubbles are in the ratio. I say this problem is of level 3. The reason is that two relations are comprised. Excess pressure in one soap bubble is 3 times inside the other. The pressure in one is 3 times the pressure in two. One relation. Volume of the two bubbles in the ratio. Volume of 1 to volume of 2. I can write this as R1 to R2 to the power of 3 because volume V equal to 4 by 3 pi R cube, the relation that exists. They are not given radius, but they are given excess pressure. Excess pressure in soap bubble, P is equal to 4T by R, where suggest P proportional to 1 by R. Therefore, if I substitute here, it is P2 by P1 to the power of 3. R1 by R2 can be written as P2 by P1 using the excess pressure relation. Substituting here P2 is equal to P2 by P1 is 1 by 3 cube 1 by 27. 1:27, option number 3. See, there are two relations we have to be used. One, volume of a liquid is proportional to radius cube. The ratio is R1 by R2 whole cube. But R is not given, excess pressure given, then immediately we have to think about pressure and radius relation. That pressure and radius, you know, P equal to 40 by R, which suggests P is inversely with R. Directly substituting the relation because errors will be minimum. Final, you have the relation and come to the answer 1:27. A body weighing 50 gram in air and 40 gram in water. How much would it weigh in a liquid of specific gravity 1.5? The question is level 2. Weight in air is given 50 gram. Weight in water is given 40 gram. What it weigh in a oil if the specific gravity is 1.5? Specific gravity means relative density is 1.5. What is its weight in liquid? So we discussed in fluid static synopsis. Relative density of a liquid is weight in air minus weight in liquid by weight in air minus weight in water. It is 1.5. 50 minus weight in liquid by 50 minus 40. Weight in liquid is 10, 15. 50 minus 50 equal to 35 gram. Direct relation, specific gravity relation. The important relation on which the questions are coming, option number 2. Simple formula with direct substitution. No any manipulations are necessary. Therefore, we kept under level 2. So coming to 13. A body floats in water with 1/3 of its volume above the surface of water. If it is placed in oil, it floats with half of its volume above the surface of oil. The specific gravity of the oil is. One is water, other is oil. Then they are placed in water with 1/3 of its volume above surface of water. Always our necessity is this. 2/3 volume of the body is inside water. When taken in oil, half of it. The same body when you taken the other, this will be V by 2. V is volume of body. Specific gravity of the oil asked. So this is specific gravity of the oil. Relative density of oil is equal to apparent loss of weight of body in oil to apparent loss of weight of body in water. That's what relation previously we have taken. So what is the apparent loss of weight of the body in oil? That means weight of the liquid displaced. Weight of the liquid displaced, if you take V by 2 into density of liquid into G is the weight of liquid displaced. What is the weight of water displaced is 2 by 3 into density of water into G. G cancels. Relative density of oil is rho L by rho W. This is nothing but rho L by rho W. 2 by 3 into 2 equal to 4 by 3. Rho L by rho W. This go to the numerator. Option is second one. Here directly thinking all the three relations which I told. Relative density of oil, weight in air minus weight in liquid, weight in air minus weight in water, or apparent loss of weight of the body in oil, body in water, or weight of liquid displaced, weight of water displaced. Therefore, we kept under level 3. You have to think all the three relations and search which one is more suitable to arrive finally about relative density of the liquid. So 15 is a level 2 question. There are two holes on one each along the opposite sides of a wide rectangular tank. The cross section of each hole is 0.01 meter square and of vertical distance between the holes is 1 meter. Tank is filled with water. The net force on the tank in Newton when the water flows out of the holes is. Just they are telling that two holes each along the opposite side of a wide rectangular tank, cross-sectional area of each hole is 0.01 meter square. There are two holes, each hole has area 0.01 meter square. The difference between their height is 1 meter. It is a water 1000 kg per meter cube. 1 meter. The tank is filled with water. Net force on the tank in a newtons is net force. Here also there is a force, here also force. Pressure is measured with this height. So pressure, if you take the net force, total force is 2 into PA. Not 1 PA, because both forces are added. Total force is added for every hole. So then it can be written as 2H rho G into A. 2 into 1 into 1000 into 9.8 into 0.01. 2 zeros cancels with this. This approximately, if you return 10, that become 200 Newton. Option number 2. So here there are two relations. P has to be substituted as H rho G, and also consider the two holes, the separate, not one force, total force, the area of both has to be accounted. The answer is second one. An object weighs m1 in a liquid of density d1 and that in liquid of density d2 is m2. Then the density of the object is. See, m1 in density d1, a body weighs, its mass in a liquid of density d1 is m1. m2 in a d2, d is density of the body. So it is weight that it is hanging. Weight, if you consider weight of the body in d1 is M1G equal to V into D minus D1 into G. Apparent loss of weight of the body written. VdG is the weight of the body in air. Vd1G weight of the liquid displaced. Subtract weight of the body in liquid. VdG weight in air. That is the relation for M1G. Similarly for M2G, if you take, it is V into D minus D2 by G. Our aim is to find D. Can take the ratio. M1 by M2 is equal to D minus D1 by D minus D2. Or M1D minus M1D2 is equal to M2D minus M2D2. Or D into M1 minus M2 is equal to M1D2 minus M2D1. Or density of the body equal to M1D2 minus M2D1 divided by M1 minus M2 is a level 3. The option is fourth one. Here the body is taken into different liquids of densities D1 and D2. Again, weight of the body in air, we can equate like that also. Weight of the body in air equal to weight of the apparent loss of weight of the body in liquid 1 and liquid 2. Accordingly, also we get here M1G can be written as actual weight minus weight of the liquid displaced. Here also weight of the body, weight of the liquid displaced. That is what it weighs actually in liquid 1 and it is liquid 2. So their ratio, if you take G and V cancels and required terms remains. This idea has to emerge, therefore we put in the level 3. The pressure on a swimmer 20 meter below the surface of water at sea level is, from the sea level, he is at a depth of 20 meter. Total pressure is pressure of atmosphere plus rho G H. It is in terms of ATM. 1 ATM is the pressure of atmosphere plus 1000 into 20 into 10. This may be written as 1 ATM plus 2 ATM, because this becomes 2 into 10 power 5, 2 ATM. 1 ATM equal to 10 power 5. And answer become 3 ATM. The solution is fourth option. Is a level 2. Suppose you forget here, this answer will be different. The pressure at a depth includes both absolute pressure, it is pressure due to atmosphere plus pressure due to liquid. Some questions we discussed on fluid statics. Let me go towards the second surface tension. Water rises in a capillary up to a height of 2 cm. The rise in capillary, whose radius is 1/4 of the radius of this capillary, will be R2 given 1/4 of R1. H1 2 cm. Their question is, what is H2? When they change the capillary of different radii, what is the changes in the height of the capillary tube? Capillary rise. You studied in surface tension concept, H is inversely with R because T is equal to half rho G H R. These are all constant. Therefore, I can write H2 by H1 is equal to R1 by R2. H2 is equal to 2 into H1 is 2. R1 is as it is. R2 is R1 by 4 equal to 8 centimeter. Option number is third. Is a level 2 question. Direct substitution. Understanding surface tension of a liquid is constant when temperature and liquid is same. Rho G constant, therefore H is inversely withdrawn. We have taken this and arrived to the relation H2. The height in the capillary tube will be 8 centimeter. So there is conceptual question, 11th one. So they given different shapes of the capillary tube inside liquid stays. When we see this, a vertical glass capillary tube open at both ends contains some water. Which of the following shapes may be taken by water in the tube? Glass tube, water, glass and water, wet the surface, theta is 90 and meniscus is concave. Both sides open, the right option is this, A. What is about this? This cannot happen if both ends are open for any liquid. This may be ideal where theta may be 90 degree. Theta 90 for a liquid and glass. This cannot be the situation now. This may be holding good for mercury where it does not wet the surface. But here option is this conceptual question we keep under level 1.